Okay, so I know so little about the humanities that I first have to start with a disclaimer. I'm an engineer. I know about design. I know about computing, and a tiny little bit about the arts, but I don't know anything about the humanities and how media systems have impacted or not impacted the humanities, whether they've operationalized it or not operationalized it. So, like a good designer, I changed what I was asked to talk about rather than talk about what I was asked to talk about. I'm going to talk about operationalizing aspects of creativity rather than media systems generally. I'm going to come up some level of abstraction and focus on creativity as something that humans do, and lately something that computers do, and how we operationalize creativity is going to be the topic of some of the things I'll show you, and what do we learn from that? And why do we do that? And so that's sort of where I'm coming from. And I want to start with something that we all know about and we all appreciate, but I want to say it again. The arts, really, the messy details matter. Even the storytelling that Nick was talking about and the games that Ian was talking about, all the details, the situation you're in, the person who's looking at it, their emotional response to it, all of that matters in whether it's good or not. And when we go into science, we remove the detail in order to study and in order to understand. And I want to qualify that. I'm not saying that we simplify, because I also agree we shouldn't be simplifying to the point where it loses its essence, and where the details are so ignored that we've lost the essence. You can have really complex scientific models that remove the details. I'm not saying simplify. So if we see that the messy details matter, and if science, and when I talk about operationalizing creativity, I'm really talking about the scientific study of creativity, not just the act of being creative. How can you operationalize creativity without losing the essence of creativity if those messy details matter? So this is just a summary. I'm going to be talking about operationalize, abstract. How do you pull away from specific situations? How do you formalize it, which moves you away from the details, but allows you to drop it down somewhere else, that whole analogy process. Once you abstract and drop it down somewhere else, you get all the details and messy details back. And when we operationalize that, what do we learn? So I'm going to look at two things. One is computational creativity. I want to look at what are insights from making computers do things that if a person did it, they would be thought to be creative. It's okay, I'm totally unfazed by guys coming up and playing with my tie. Is that okay?
Thank you.
Okay. 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 And I'll be looking at three areas. One is where computers actually do simulations of creativity, or where they synthesize. We've seen lots of examples already. I mean, the storytelling is a synthesis process. The computer is actually generating the story. And I'll be talking about evaluation, which is a pretty tricky thing to talk about to people in humanities. And every time I try, they shoot me down. I'm going to try one more time. And that is that computers could actually tell you if you're being creative or not. You don't need people out there, which is a little bit provocative. And I also want to talk about insights from interaction design in terms of operationalizing creativity. And this comes back to Brenda's talk a little bit, and that is how we actually interact with these devices matters. And that when we're talking about creativity specifically, there are certain ways of interacting with these systems that lead to us being more creative. It enhances and augments our creativity. And I'll talk about those kinds of systems too. So I'm going to go through some examples. This is just one example by Céline Latulippe and Dave Wilson at Charlotte. So it's not my work. Some of it I'll talk about. Some of the work I talk about will be mine and others won't. And they did some work abstracting dance. And this example on the left is when you have dancers on the stage in real time, from cameras above and from the sounds of the dance, you're generating these patterns of dancers as amoebas. And the dancers see this and interact with it. And it's an interesting idea that you would use the computer to abstract the physical phenomenon of humans dancing, and it's choreographed, it's not improvisation, and use that to make it a little bit of improvisation. So it becomes this loop. And when we get to the end, we'll talk a little bit about computers being partners in creativity, not just doing what we tell them to do, but actually becoming full-fledged partners. And then the other side is looking at audience engagement real time and seeing how that affects how a person dances. Now that's only possible because we've sort of abstracted data from the audience now, and we've created this visualization of it that then has an impact on how the dancers perceive the impact of their dancing. It's kind of circular, but an interesting idea. Well, let's try that. That's better. This is another project. This is one by Rob Saunders and John Giro, and this is simulations of social creativity. Now the idea here is that you have this multi-agent system where each agent is a designer, artist type agent that generates a bit of artwork, sends it out, and everyone evaluates it. Social creativity is a fascinating concept that when you think about it, creativity is not synonymous with art, although many artists might think it is, in the sense that you can declare that something is art, but you can't declare that it's creative. It's creative if others think it's creative. And so creativity as a social construct can be studied through these multi-agent systems, and that by studying them, we look at the characteristics of social creativity from the generator's perspective, from the evaluator's perspective, and the interaction among them, that what I produce as an artist or as a designer is going to be affected by what I think you think will be creative. And then your evaluation of that will again affect what I do next. And so when you simulate this, you can see certain things happen, and this is just illustrating how you begin to form what might otherwise be called communities of practice, people who have a shared idea of what is creative and valuable, and another group of people like other things. And by simulating that, we can see that emerge out of the system. So we learn something about social creativity by getting the computer to simulate social creativity. This is another project. I'm just going to go through a bunch of these because at the end I want to try and pull it together. Rather than go into any of them in any depth, I'm going to do a bunch because I think there's some big lessons to be learned by operationalizing aspects of creativity. This is a virtual world. I loved Brenda's book because I'd been working in virtual worlds for about 10 or 15 years before I actually read the book, and I was like, yeah, someone else thinks this is fun. So this is a virtual world with sheep in it because the PhD student that I was working with in Australia was in Australia, and there's a lot of sheep in Australia. And the idea was to look at how we could use curiosity as the reward function in a learning system. And we put these sheep in here, and basically they learned how to use this food chute, and I'll explain that in a minute, but we put anything in there. It was a food chute, or it was a truck, or it was a target practice, or it was a paint gun system, and we wouldn't tell the sheep what to learn, and we wouldn't tell them how to learn it. We would just put them in there, and based on this one curve that tells you about hedonic value, when things become maximally pleasurable, not in the beginning, not the first time you see it because it's too novel and you don't know what to do with it, but if you see it a few times, you become really curious about it. If you see it for a really long time, you kind of get bored. So we use that to direct the learning. And and found amazing things. So that's just about to do it. That's my favorite part. So these sheep learn how to use this food chute. Again, they don't know anything about food chutes or anything. And some of them would learn if they pushed the button, food would come down and they'd go over here and eat the food. And some of them learned that if they pushed the button 3 times, they'd come down and they'd get 3 pieces of food, which is great. Some of them learned to just wedge themselves right up there. And then they could push the button and eat at the same time, no moving required. And so every sheep learned different things and optimized what it was that they were able to do. But we found a lot of creative behaviors emerging from this because what was guiding them was this model of curiosity. So what are we operationalizing here? We're operationalizing human curiosity. And we're putting it inside these so-called non-player characters in a virtual world. And they're not only becoming believable in the sense that we can relate to them as humans. They're sheep, but we can relate to them as humans. But we find that they come up with pretty creative ideas. Actually, this is a funny story. We put it in these sheep, the model of curiosity, and we allowed them to sense their environment using context-free grammar. So they could sense anything. We didn't have to tell them what they could and couldn't sense. They could just sense anything, label it up, and recognize it next time. But they kept being really curious about each other. And so they would all start to flock together. And they would just sit there and go, ooh, sheep, sheep, look, sheep. And, and they didn't learn anything else. We actually had to disable their sensor ability for other sheep. And she said, you know, they're just like real sheep. All they do is flock around and stare at other sheep. But we got rid of that. OK, so then this is another project of mine on coevolutionary design where we again, operationalize that phenomenon that we could observe in real design, human designers, real designers. That was a slip, because computers are real too. But we observed in human designers this ability to move between the problem definition and the solution. As I said in the beginning, I was given the task to talk about something I didn't feel I wanted to talk about, so I changed what I was going to talk about. And that happens in design a lot, where you'll be looking around in this so-called solution space, and you'll find something really awesome. And rather than make it fit the problem you were given, you change the problem you were given. And this happens a lot in design, and we're able to use that to map that onto things like the Opera House, which, in fact, is an interesting design solution because it didn't satisfy any of the requirements that it had initially. Not a single one. It did not fit on the site. They had to reclaim part of the harbor. It did not have a single hall. It had 2. It did not have enough seating. Absolutely everything. Its cost overrun was 1,000 times what budget it was allocated. I mean, it was just outrageously bad at that. But look what we got. We got this icon that is far and beyond anything anyone anticipated. And the moral of the story isn't, you know, make sure your design doesn't satisfy any of the requirements. The moral of the story is that that's a normal phenomenon in design, that we can now abstract that, operationalize that, and we can build computer systems that design that way instead of optimizing against constraints, which is a typical engineering approach. And now this idea of evaluating creativity. One of the things that we rely on is human judges to evaluate whether, in fact, something is creative. And that's OK. But is there anything we can, I mean, that's fine. In fact, we're the ones we're trying to please, right? We're not trying to please the computers. We're trying to please the people. And so that makes sense. But again, why operationalize it then? Why build models of what makes something creative? Well, it's just like building models to get computers to be creative. We could understand it better if we could operationalize it. Maybe we would tweak it and modify it, but we could understand it better. And everyone associates, everyone in the lay world, not in the world of academics who study creativity, but everyone says, oh, creativity and novelty are synonymous. And in fact, that's not enough. And So one of the things I propose is that there's three things. It's got to be novel, it's got to be valuable, which is important. In my engineering training, they didn't even care about novelty. What they wanted was it actually works. And I think in the arts, it's more about novelty. You know, you have to be different. It doesn't have to be useful, but it has to be different. And that somehow there's a balance between the two, but even more when you come across the kind of creativity that really is earth-shattering, it's usually very surprising. And so I've built AI models of all three of these. You are running through a design problem, and you place it in the designs, the space of possible designs, and through conceptual clustering and measurements of similar but different, you can actually say whether that's a creative solution or not. Now, I'm not sure whether we want to relegate all evaluation of creativity to computers, but it's interesting to see what it says.
No.
It could be part of the discourse. Now, come on. And now let's just step aside now. So those were a lot of examples of making computers be creative or abstracting aspects of creativity and giving that task to computers. Now let's step back and look at interaction design. And some of the things that I've been looking at is how does this perceptual space that we're in, how does that affect our cognition? How does it affect the way we think? And are there certain things that lead to people being more open to or capable of coming up with creative solutions or creative thoughts? And again, throughout my whole education, creativity just was not part of it. It was, you had to get the right answer. You had to give the teacher what the teacher was expecting. Yet the society values creativity. And so if we're going to start putting computers into education, we should at least put in the ones that open it up to facilitating and augmenting creativity. And as part of that, we did a study. This is just one slide of a lot of theory behind it. But we compared on similar tasks using a keyboard and mouse to using a tangible user interface, and found that the designers actually did think about different things, even though the tasks were very similar and they were the same designers being compared. And that the things that they thought about were at a higher level of abstraction. They changed the problem definition more often, which is a hallmark of being highly creative. And just all sorts of things associated with the cognition of using tangible user interfaces had to do with creativity. So there's something there. There's something to be said for thinking about interaction design in terms of augmenting creativity. And when Brenda was this morning doing this sort of thing to show how certain interactions with the computer, because they require mental rotation and all sorts of spatial reasoning that girls aren't very good at, I suspect that if the girls could actually do that physically, if they could move their hands around like that, it would be much easier. But if you have to do all that basically with your hands tied to your side or glued to the keyboard and mouse and you can't move them, then that's where we have the problems. Not that the interaction itself shouldn't have any of that, but we have to let people move when they use computers. And then finally, the final project I want to talk about in interaction and design is this idea of crowdsourcing and collective intelligence, because I've been doing some projects in this lately. And this idea of diversity is just fascinating to me. I mean, we're all here because we're diverse and we're interdisciplinary, or we appreciate interdisciplinary. But anyone who's ever tried to collaborate with a diverse group, like we heard this morning, it's really hard work. And there's something about crowdsourcing that gets rid of some of that hard work. The computer actually can mediate that in ways that we can't mediate that when we're all in the same room. And one of them is, I love this cartoon, it's very old. On the internet, nobody knows you're a dog. And when I first saw it, I thought, why would a dog be on the internet? I totally didn't get it. But I have a brand new insight into this. In everywhere else but the internet, what happens is your credentials go before you. I apply for a job at NSF. What do they get? My CV first, right? They didn't know me. They just saw me on paper. And when I applied to jobs in other places, what do they get? My CV. And maybe letters of reference, which is what people think about me. But they don't get me. And on the internet, it's you first. No credentials. If you go into one of those crowdsourcing sites and you put up an idea or you put up a design, you could be anyone. Okay, you could be a dog. But if it's a good idea, they really don't care. It's really your ideas. It's you that comes first. Your credentials follow. That's a great way to mediate diversity. If you don't care what to educate, does she have a computer science background? Well, no, and then their degree, then she can't be in a computer science department. You know, that sort of attitude.
But is it true that it becomes a meritocracy on the internet, or do people really bring in their assumptions about who other computer users are and what they assume that what their backgrounds to be or experience? And so is it really, basically, are people just taking advantage of passing online, and are you suggesting that that's a strategy for kind of more empowered using?
I think it's a mechanism for mediating the difficulties of diversity. And how we do that, we haven't really figured out how to do well, because I did say that you come first, but your identity comes right fast behind you, real fast. Whether you describe yourself, self-described identity, or whether people ascribe an identity to you, it happens really fast. And this is an area of research, and that by operationalizing this, we can then study that, as you are, the role of identity in online communities.
Right, it's just the issue that people, other users of the system already have presuppositions that come from the society in which they're embedded. So it's just a little dangerous to suggest passing.
You could say on the internet, everyone assumes you're a white man.
Right.
Right. That's right. That's right. But when we talk about research that operationalizes these ideas, we now have a language for talking about that where before we didn't. And we have a way of formalizing it, abstracting it, and thinking about it, simulating it, and trying different things. So I did try, in all of these projects, I sort of glossed over them to get to the point.
Account for how these phenomena take place actually in the computational infrastructures, and whether the infrastructure is supporting this kind of assumptions or whether they're helping us to support them. So I think that's useful.
Right.
Yeah. So I'm thinking about the three attributes you had in terms of thinking about creativity and operationalizing, and the notion of novelty. And so my question is, when we think about, from the human side, saying something is creative, we might see novelty there, but often there's something that's deeper. There's a reference. There's something that there's comparative to first of all understand that it's novel, and to understand that if there's novelty there, that is substantial enough to be recognized as being something creative. And I don't necessarily see that in the model that you're presenting, and that's really based upon being able to really go back and reference, the situation, the history, the whatever, is allowing you to.
So, and I agree. And then again, I glossed over it, and that the ideas there, those three things. First of all, that novelty, value, and surprising are different characteristics. And any one of them, when you dive into it, again, by operationalizing it, by creating an AI model that is called the novelty detector, which has happened in multiple fields. Robots use it all the time in order to figure out whether they're in danger or not. When you operationalize it that way, you think more deeply about what do we mean by novelty in the space of creativity and creative works. And then you operationalize that aspect of it into the AI model, and which comes to my last slide, and then we can open it up for questions. And that is, what are these insights? So when we look at computational creativity, by operationalizing aspects of it, whether it's the evaluation or a simulation or a synthesis, something that makes the computer itself creative, we get a better understanding of human creativity, which is pretty cool because it's on the computer. That the computer actually allows us, by abstracting, to to think about human creativity more deeply. It also, it gives us a new kind of creativity that isn't like Nick's work. That wasn't based on human cognition, unless you think humans are just randomly taking sentences out of their stories just to create ellipses. I doubt it. I mean, maybe a really stupid human might do that, but that's not necessary. It wasn't done because you think humans do it that way, but because that would be an interesting way for computers to try and achieve something. So we come up with things that are not modeled on human cognition. And finally, it just gives us new languages and formalisms for talking about creativity that we did not have before, when we didn't have this interactive system being creative. When before all we had was theories and writing books. We didn't have these kinds of systems that really engaged us to talk about creativity in a different way. And then interaction design, what are the insights there? Interacting with digital systems, media systems in general, it changes our perception. If it changes our perception, it changes our actions. If it changes our perceptions and actions, it changes cognition. And we don't really understand that part yet. And as a group of people, or I'm really fascinated by creativity and think it would be nice if people were educated to be more in ways that encouraged more creativity. It would be really cool to try and understand that relationship between interaction design and creativity. And then finally, this whole diversity thing, now that we've really scaled up and the internet is being used by so many people, that there's enough people out there to take any problem and throw 100,000 people at it. You could never do that before. And I'm talking about thousands and hundreds of thousands of problems, each getting hundreds of thousands of people. This diversity is going to really be fascinating to see how that unfolds into a different kind of interaction that we haven't had before. And now I'll take questions, please.
So this was great, because it really, I think, for me, operationalized what it means to say operationalizing. So as much a kind of tutorial in how one approaches that task. And so the question I have is actually maybe a follow-up on panelists, which is, from a humanist perspective, those three concepts, novelty, value, surprise, are essentially cultural constructs. What counts as signs of novelty vary from culture to culture, just as what counts as signs of art, what counts as modes of expression that are privileged over others, and so on. So you've now created a model, based on some enculturated understanding of those, which is what anyone would do, and you would do that in any context. And so I wonder if you've had any opportunity to now kind of look back to see how your model that operationalizes these three terms might be reflective of a particular cultural kind of sensibility, however we might bound culture. The culture of engineering, the culture of a US-based approach, the culture of a Western English language culture approach, and so on. And that, is there an opportunity to think, and I think we've been talking about, reflexive software development, to think about how you might engage someone who's thinking along the same lines to operationalize it from an entirely different, tangential kind of notion of novelty, surprise and value.
Yes, in fact, I've given this talk to a few very different kinds of audiences, and it really resonates with engineering designers and product designers. It totally doesn't resonate in the arts and the humanities. They just look at that and they go, I don't even know what you're talking about. Like that kind of disconnect. And they use words like intentionality. I mean, maybe you use, I'm not saying they as if they're not you. Intentionality and aesthetics and emotional response. Those are the things that are associated with creative works, not novelty, value, and surprise. So you're right. There's a lot of cultural expectation in framing that problem at all. But let's frame it.
Right.
Let's talk about it.
I just attended a Music in the Brain conference, and one of the researchers there, I'm curious if you've heard of it's David Huron from Ohio State. He's done a study on the psychology of expectation and really looking at music and how that comes into play. And it really resonates with a lot of what you're talking about. Specifically, what they went into is this notion of goosebumps. And, you know, in those transformative moments of high artistic engagement, you sometimes have this goosebump moment. And they've looked at it musically and sort of tracked this notion of expectation and surprise, but there's like a magic formula of mixture of how much of both in order to get you into that very visceral response where you're probably having a highly charged memory-making moment that sticks with you. And they looked at it just in terms of pieces of music that build that expectation and surprise, even if you already know it. But there's a certain chord progression that resolves in a way that just is pleasing.
Yeah.
In a
So-
Western tune.
In a Western, well, no, not throughout cultures. They looked at that too. There's some of it that's learned, but they look at dissonance and consonance, and they span different cultures. So that even in babies, they had this, like a videotape of a baby looking at something that had a pleasing resolution, and then another light that was just a bunch of noise that had a lot of tritones, and the baby would look at that for a half a second and then move away.
Yeah.
But the notion is that there's this sort of a surfing that happens in music, and I think you can find it in story as well, where you
And in humor, So when we've been looking at surprise, the two examples of the places where they have studied this to a fairly large extent is in music, because music is very rule-based. And because it's so rule-based in the sense of what is pleasing to the human ear is highly constrained, cultural. So what's pleasing in Western music is different to what's pleasing in Eastern cultures, and Chinese cultures are different again. And because it's so highly constrained, moving a little bit out of that, just a little bit, not too much, just a little bit out of that is surprising. And there's a very strong emotional response to it. But the same with jokes. What jokes do is they set you up to expect the next thing in the story, and then they don't give you that, they give you something else, they do a pun or something. And so this notion of surprising can be operationalized in the sense that we could build a computer system that could generate a surprising event, and we can build a computer system that can recognize it. So it's really fascinating that something that we feel emotionally can be operationalized.